Up until today, you guys, we've just been doing logs, and your logs have various bases. And anything that we wanted to actually quote solve for, we didn't really use a calculator for, except for your basic math. There's two special logarithms that you can use in which you can actually put them into your calculator and get values. Okay? The first one is called the common log, and the second one is called the natural log. Okay? The common log is log with a base of 10. And that is the log that is on your calculator. So anything that's like log base 10, you can actually find a value for. And then there's another log, and it's a base e, okay? And e is a very special number that you can use, and you can find that as well. So we're going to be, the first section we'll be looking at is what's called common logarithms, okay? Again, we write that as log base 10 of a value. And because it's a common log, we just simplify it by writing log of x. So if you see a log without a base, it is assumed to be base 10. Okay? So now, from now on, if you just see log and there is no base, you're going to assume it's base 10, and you're going to assume it's the one you can use in your calculator. Okay? Unless if it has a different base, then we go through a different process, what we've been going through. Okay? Then there's one that's called log with the base e. We call this the natural logarithm, and we write this as log base e to the x. Okay, and how we can rewrite this as log or ln of x for natural log or log natural. Okay, so when you see ln, it's really log base e. Okay, and so we'll be using these two properties today. This next section is just going to be the log base 10. Okay? We're going to show you how to use both the log and the ln on our calculators, so you know how to actually use your calculator and know how to evaluate. Each calculator is a little bit different. So let's go ahead and get our calculators out. You should have two buttons on your calculator, one that says log and one that says ln. Okay? Some people have it down here, some people have it up here. Calculators can be different in the fact that, oops, let me make this bigger. Sometimes you punch in what you want the log, you punch in log first and then the number, and other calculators you punch in the number and then log, kind of like what we've been doing in the past with square roots and stuff like that. So you want to make sure that you have the correct way of using your calculator or be able to recognize which way the calculator is used, okay? So we have a few things we're going to evaluate here, and we want to make sure we get the right answer. So on your calculator, log 10, so log base 10 of 10, go ahead and type in log. If you get the word error, then you need to punch in 10 before you hit log, okay? So on your calculator, go ahead and try to see if you need to do log and then 10 or 10 and then log. And what you should get the answer 1. Okay? Is everyone able to find their log? Okay? So the answer for log of 10 is actually going to be 1. Okay? This is actually kind of a special log, because if I would actually write this the long way, this would be log of base 10 to the 10. And do you remember what this property is right here? What that equals? When the base equals what's evaluating to? It equals 1. So like if the base equals what it's evaluating to, the answer is 1. So notice how log base 10 of 10 actually equals 1. So look at that. That's like a special log. Okay. Let's try log of 1,000. So punch in 1,000 on your calculator and then hit log, or punch log and then hit 1,000, and you should get the answer 3. Okay, so on your calculator, punch in log and then 1,000, or 1,000 and log, depending on what your calculator does. You got yours to work? Okay, so let's do ln. So ln is the same type of process. If you had to hit log first, you're going to hit ln first. So notice how my button's right there. We want to do the ln of 5, so I would do 5 and then ln, and you should get 1.609. Is everyone able to do that on their calculator? Alright, try, the ln of e is going to be a little bit different, okay? Now on mine, I have to hit, I have a second key, it has E to the X. Does everyone see that on there? If you have to hit ln second, like you hit the number first, you're going to do second and then E. Oops, that didn't work. Second and then E. No. I'm trying to think how I did mine. Oh, 1, second, E, and then ln. No, that's not right. Mine is a little quirky on this one. Basically, if you hit ln first, do ln, second E, and then it's going to ask you for an exponent. Type in 1. Okay? So it's 1. The answer is 1. But in my calculator, I got to do it second. I always get this wrong as to how I'm supposed to do it. Oh, mine just automatically did it. Mine's 1. Okay? So, do you hit ln first? So do ln, and then do the second, and then the E key, and then type in 1 for the exponent. Okay? And this one, I'm going to show you, is a special one as well, because, watch this. This is really log base E to the E. Okay, because remember how up here I said that it's log base E is ln, right? So this really can be rewritten as log base E to the E. Well, what is the same base being evaluated to? What does this property say? It's 1, right? So that's ln and E from now on. When you see it, you can write it as 1. Okay? Alright, try log of -7. What do you guys get in your calculator?
Nothing.
Error. And why do I get error? It's a negative log, right? This value cannot be negative. This is no solution. Okay, so you guys are going to need to know how to evaluate logs. And so these, when you see logs and ln's like this, it says evaluate, it wants you to put in your calculator. Okay? All good with that? Okay. Alright. So what we've had before, you guys, on solving for, again, logarithms are solving for exponents, okay? We have that same process here in which what we did last time, right? But we're going to be able to use, by using the same base as log 10, it allows us to then actually find values, okay? So when we say we have something that has an exponent in it, we've been trying to find the same base, and then we're able to solve for the exponent, right? Because we cancel out the same bases, etc. So our same base is going to be log base 10. Okay, so that's the base we're going to raise everything to, and then when we do that, it allows us to actually find a value. Okay? So, looking at 5/2 squared equals 130. So, we're solving these using logs on both sides. So, I'm going to raise both sides to the log base 10. So, I'm going to do log, and then I just write 5/2 to the x, and that's going to equal log of 130. Okay, so I'm going to raise to same base, and then of log base 10. I don't have to do base 10 there because it's just assumed. Okay, so again, remember if there's no base, then it's assumed that it's a log 10. Okay? Alright, so then you guys just got done working with logs that had 3 properties. They're being added, subtracted, or to the power. So notice how I have 5 to the power of 2x, right? So what can I do with that 2x? I can bring it down, right? So I'm going to bring it down to 2x log 5 equals log of 130. Okay? So I'm trying to solve for my variable. My variable is what? X, right? So how could I get x by itself? What could I do to get x by itself? Not subtract, divide. I'm going to divide. I'm going to divide by everything except for that x. So I'm going to divide by 2 log of 5, and I'll divide by 2 log of 5. Okay, so you want to solve for x. So now it's going to be x equals log of 130 over 2 times log of 5. Well, I can put those in my calculator now, can't I? Right? Because I just showed you how to evaluate them up here. So I'm going to, in my calculator, going to do log of 130, and that's going to be 2.114, and then I'm going to do log of 5 and times that by 2, and I'm going to get 1.398, and then I take 2.114 and divide it by 1.398, and I'm going to get 1.512-ish. Approximately 1.512. Okay? So, by raising both sides to the log of base 10, it allows me to get to where I have just logs, and I can plug those into my calculator and get an actual value. So basically, if I take 5 and I raise it to a 2 times 1.512, I should get 130. So let's see. So if I take 5 and I have 2 times the 1.512, so I'll times that by 2. So it's 3.24. So I'll take 5. I'm going to raise it to what did I say it was? 032? No, that's not right. 5, raising it to, let's see, wait. 1.1, let's do this 2 times, parentheses, no, it's not going to work. I'm trying to figure out how this calculator works. 2 times 1.512. Okay, 3. So this is going to be like 5 raised to 3.2024. So I raise 5 to 3.024, and that equals approximately 130. You will want to check it. Yeah, you want to make sure it works. But that's, you see how I solve like that answer then makes this a true statement. Right, so this is the check. So then I took my x value and I just plugged it in there. So I had 2 times the 1.512, raised 5 to it, and then it equals 130. Okay? Alright, so let's try the other example. So now, I have 3x to the negative 2 equals 12. I'm trying to solve for an exponent, so therefore I need to work with logs. I want to raise them both to what base? Log base 10. So I'm going to do log of 3 to the x minus 2, and that's going to equal log of 12. Okay, what property can I use now? The power property, bring it down, right? So I'm going to bring it down to x minus 2, and that's log of 3 equals log of 12. Okay, so now that I brought that down, okay, I want to solve for x. So now I have an x minus 2 multiplied by log 3 equals log 12. So how could I start solving for x? What could I do? These are being multiplied, so how would I get rid of something being multiplied in front of something? Divide. So I'm going to divide by log 3 and divide by log 3. Okay? So now I'm left with x minus 2 on this side equals log of 12 over log of 3. And how could I now get x by itself? Yeah, add 2 to both sides. So I get x equals log of 12 over log of 3, and I'm going to add 2. So now I can plug those two into my calculator. I can do log of 12. Okay, and I can divide it by log of 3, and then I can add 2. And that's 4.26. 4.26.
So how come these 4 and 2? How come you didn't divide by it and log 2?
Because they're both being multiplied, so it's like if I had, it's one parenthesis. So it's not like x minus 2 is 2 separate things, it's like one thing. So it's kind of like if I had 5 times x minus 2. So it's always 5 like x minus 2. I would divide by the 5 first, right? And then I would have the 2 by itself. Okay? Alright, so if I would take the 4.26 and plug it in here, I would have 4.26 minus 2 equals 12. So let's see, that's minus 2. So I'm going to raise 3 to 2.6. And that equals approximately 12. So that is true. That does work. Okay? That makes sense? So this is my check. You just plug that value back in. Question? Okay. Ready to move on? Alright, flip. Okay. Now, I'm going to have you guys try this one. However, I want to mention one thing because it's a little bit different than what we saw on this side. So the one thing I didn't really mention before is that whenever you have any of these, you want to make sure the exponent portion is by itself. Okay, so notice how I have 5 to the x. It's its own by itself, right? There's nothing added or subtracted or anything like that. Notice how 3x minus 2, that portion is all by itself, which is different than you have on this side. I have 2 to the 3x plus 5. Notice how there's more on the left-hand side. So before you do anything, before you raise it to the same base, you got to get everything over to the right side that's not the exponent. Okay? So what should I move over to the right side? The 5. So we want to move that over. So we're going to do 2 to the 3x equals 10. Okay? So now it's what we had from the beginning. Okay? So you want to make sure that if you have anything on the left-hand side where the exponent is, you move it to the right-hand side first and consolidate it with that constant. Does that make sense? Now you can do this one. So what's our next step? Yeah, you want to raise it both to the log. Okay, so go ahead and do that. So we have log of 2 to the 3x equals log of 10. And now I'm going to see if you guys can't work through that. So try to work through that to get an answer. So on this, you guys, once I have log 2 to 3 x equals log 10, I'm going to bring the 3x down. Okay, I'm trying to solve for x, so I'm going to divide by 3 log of 2. Okay, so then x equals log of 10 divided by 3 log of 2. And if you do the math in your calculator, you should get an answer that's 1.107 approximately. Okay. Now, I'm going to warn you guys, a lot of students like to plug the whole expression into their calculator. If you're able to do that, that's fine, but be very, very, very careful and use parentheses as you need to, because log base 10 divided by 3 log 2, some calculators, if you don't watch your parentheses, it's going to not do it correctly. So if you did not get this answer and you put it into your calculator as one expression, double check how you use your parentheses. Yep. So, questions on that? Alright, so now the difference between this E example is that we have exponents on both sides, right? Why? Yeah, because we do. So, what we want to do is start by getting the same base. So what same base do we want? Log. So we just do log 5 to the 3x equals log 8 to the x minus 1. Bless you. So now we're going to use our power property. So what we're going to do with the exponents, bring them down, right? So I have 3x log of 5 equals x minus 1 log of 8. Okay, this is where you're all going to hate this. Okay, I'm gonna walk through this. There's 2 different ways you can do this. At this point, you could decide to convert the logs that you know into numbers and work with numbers, or you can work with logs. I'm going to do the logs first, and then I'm going to show you the numbers second. And then you, as a student, decide what works best for you. Okay? Because remember, logs with base 10s, those are numbers, aren't they? Right? Okay. So I'm going to walk through this. We need to solve for x. So I have an x on this side and x on that side. So the first thing I need to do is distribute this log of 8 to each one of these. So I'm going to do 3x log of 5 equals x log of 8 minus log of 8. Okay, I did the log to the x and I did the log to the negative 1. Okay, you have to distribute that out. Okay, at this point I'm going to bring this x log of 8 to the left side because I then need to pull out an x because I have two x's now, right? So I'm going to bring this over. So I have 3x log of 5 minus x log of 8, and that's going to equal negative log of 8. Okay, so I'm trying to get the x's to the left-hand side because then I'm just going to pull out that common denominator or that common factor of an x. Does that make sense? Okay, so now I have the x's on both sides. I'm going to pull an x out because that's a common factor. So that's going to become x multiplied by 3 log of 5 minus log of 8. And that equals negative log of 8. Okay, so I'm going to ask you, how do I get x by itself? If it was 5x, what would I do? Divide. So I'm just going to divide by what x is being multiplied. So the 3 log of 5 minus log of 8. And divide by 3 log of 5 minus log of 8. Okay, if I plug all of that into my calculator, this is where you need to be very careful. Figure out what this all should be in a parenthesis because that log of 8 is being divided by this whole value. So be very careful you plug it into your calculator. When you plug into your calculator, you should get approximately negative 0.756. Okay, so that's working with the words log all the way down. Now, let me show you something that students tend to like better. At this point right here, you guys, I can convert these into numbers. Okay? So basically, this is like x times log of 5. So or 3 times log of 5, right? So I could, in my calculator, do log of 5 and multiply it by 3, and I'm going to get 2.09. So this right here. This really is 2.097x, right? This right here?
Because you did.
Because I took log of 5 and multiplied by 3. Does everyone see how I did that? Okay, so now that equals the x minus 1, and then log of 8, I can plug into my calculator. And that's 0.903. Okay, so I took log of 8 and calculated, that's 0.903. So this value right here is log of 8, and this value right here is 3 log of 5. Alright, now you just have numbers. Is that easier to work with? For some it is. Right? Because then I can do this whole process with just numbers. So at this point it would just be the 2.097x equals 0.903x minus 0.903. Alright, I did the same thing where I distributed to both. And then I threw the 0.903 over to the other side, so I did 2.097x minus 0.903x, and that equals negative 0.903. Well, I can calculate this now, can't I? Right, 2.097 minus 0.93. So I do 2.097 minus 0.903, and I'm going to get 1.194x, and that's going to equal negative 0.903. Do you see how numbers might be easier for some? Divide by the 1.194, and hopefully I get the same answer. I get the same answer? Yes, I did. Negative 0.756. Okay? So, you have to start out with the logs and get them to this situation, and you can work through them with logs, or you could convert your logs into numbers and then work through it through the math way. You decide which way works best for you. I see it both ways on tests. Matter of fact, I see it kind of multiple ways on tests. Like some people turn some logs into numbers and keep logs in the other and then wait till the end. So you decide, but realize that what you have here are numbers. They are numbers. That's the whole point of the log base 10. It allows us to give us a number. Here's my question to you guys. So we have all these different bases that we can use, but we only can use log base 10 in our calculator, right? So wouldn't it be great if I could tell you there's a way to do that, to take any base that you have and actually get it into be a log base 10 to get a number? Yeah, that would be fantastic. So guess what? I have that for you. It's called the change of base formula, right? So the change of base formula is you can take any log that you have, and notice how it's log base of something, and if you rewrite it by log of m over the log of the base, so the base goes on the bottom, okay, you actually are creating a log base 10 situation. So here's an example. If I have log base 8 of 32, I could put in my calculator log of 32 and divide it by log of 8, and I'll get the same answer. Okay, so let's do that. Let's do log of 32. I'm going to divide it by log of 8, and then equals 1.67-ish, 1.667, approximately 1.667, right? So this is actually asking 8 raised to what gives me 32, right? That's what it's asking me, correct? Hopefully that's a good answer, good guess. All right, so let's see. Is 8 raised to 1.667 32? Look at that. It works.
Yeah.
Yay! All right, so now try log base 4 of 18. Change it. It's a change of base. Change it and find a value. I don't know. All right, so did you guys get log of 18 over log of 14 or 4? All right, so that's the change of base. So then you should get, I got an answer of approximately, this was 1.255 divided by 0.602, and that's approximately 2.085. So if I raise 4 to the 2.085, that should equal 18. Okay? So 4 to the 2.085, and that equals 18. That is your solution. So again, you can't plug this part into your calculator, can you? So it's hard to find that. So if you convert it into the change base, you can now plug it into your calculator and you actually get an answer. Good? Alright, so that's common logs, guys. No. Flip. I told you today we had 2 units. Okay. So we have 2 logs that we talked about. We talked about how we have a common log and we have a base E log, or the natural log. The process that we're going to go through is exactly the same, except for instead of using log base 10, we're going to use log base E or ln. So we're just going to show you how that works. The difference is you're going to, when you see an exponent, if you see an E anywhere, then you're going to be using the ln versus the log, and that's how we're going to kind of break it down, okay? If you guys ever invest money or want to make money a lot faster than just a standard bank, you're going to want to find something in which the interest compounds almost all the time. The more that interest compounds, the faster your money grows, okay? Well, they have found in this world that like constant interest actually has a value. So this is something we're actually going to use in the next unit here, but this 1 plus 1 over x, where the x actually is how many times something is actually compounding, so daily, hourly, minutely, whatever. This value in the middle here is a number that then they have designated as E. So we're going to be using this value. So this number, if you plug it in, actually is a 2.718281 whatever. It's kind of like how pi goes on forever. This is a number that, depending on how, if the more frequently you actually compound something, it gets closer and closer and closer to this value. Okay, so this is a mathematical number. And they've called this number E, they've given it a value of E, and they call it the natural log. So in the financial world, if any of you guys are going into the financial industry at all, this is a number that you will live and die by. Okay? So they just show you in this chart how the more that you compound, like if I compound once, my value is 2. If I compound 1,000 times, then it gets closer and closer and closer to this number. So this is kind of like that asymptote. You'll never cross over it. Okay? So again, E is going to be the 2.718281 da da da. And what I just want you guys to realize, it's a number. It's not a variable. Okay, because we're so used to seeing letters and thinking they're variables and we solve for them, but E is a number. It's actual value. Okay, so whenever we use it, this is what we're using. We won't be graphing E's, but I'm going to show you the graph very quickly just so you kind of can see that it's very similar to what we've been using. In this situation here, if I would do an X and a Y, I would plug in my values where it would be like 2 and then be E to the 1 plus 1. This is my equation I'm using right here. Well, E to the 1 is like 2.718 times 2, which is like 4 plus 1. So this becomes like a 6.4. Oops, sorry. If I do 2e to the squared and add 1, that's like 2.718 whatever squared times 2 plus 1, so that's going to equal like 15 something. Okay, and so you get values when you plug this in. Okay, when I plot this out, my graph is going to look something like where it goes like this. Okay, notice how this is following the a b to the x plus k. This would be minus h up here. So this right here is my asymptote 1. Okay. This 2 represents my A if it's reflected or not, and then E is like my B. Okay. So B, if it's greater than 1, was it growth or decay? Growth. A, if it's positive, is it reflected? No. Your asymptote for y equals k, so that's going to be y equals 1. My y-intercept was x is 0, so if I put in 0 for E, this becomes 1, so 2 plus 1 is 3, so this is x equals 3, or x equals 3. I mean y equals 3. Okay, and these are my points. So you could graph it just like you would, but what I want to show you is the same concept. Okay, you still have the same exponential growth. Okay, you're not going to have to graph it on a test. Okay, that's why I'm running through it really fast. I just want you to see that you can still work it. Yeah. Okay? Well, we're not going to graph on a test. Okay? Alright, so that's just more to show you how it works. So now let's talk about how we solve for this. And we're only doing this page, not the back. Okay. So we have a couple things going on with this. So we have been, with the logs, we have been evaluating logs. We have been rewriting them, we have been solving them, and that we still have the same process with the natural logs. But our base for the natural logs is not log, but ln. Okay? So the process is going to be the same, except for that when you see E, you're going to raise everything to ln instead of log. Okay? So we have those. So your same base, when you see E, is going to be ln, not log. Okay, does that make sense? Okay, so let's walk through how we would do this. If we want to evaluate using the properties of logs, all right, well, what do we know about, excuse me. Well, there's two properties with ln's that make our lives a little bit easier. So if you recall, we had the property of like log of base to a base. What was that property? What did that evaluate to? That evaluated to 1. If I had log or if I had base to the log base, what did that evaluate to? Where the base and the log of the base were the same, what did that evaluate to? 1. Okay? So these were two properties that when we used them in logs, our answer was 1. Well, we have the same properties here with ln's and e's. So, e to the ln, if I have e to the ln, so e to the ln actually equals 1. Okay? So if this equals 1, what would my answer be here? 21, right? So therefore, this is going to equal 21 because the e to the ln evaluates to 1. So you're like, okay, not quite sure how that all worked out. So what happens is, if you recall, I said ln equals log base e, right? Do you remember that in the very first page? So if you flip to here, I said ln is really log base e, right? Yes? Okay. So I could rewrite this. This is just a proof, you guys. I could rewrite this as e. Well, what's ln? Log base e to the 21. Right? So that can be rewritten like that. Well, what's the e to the log of e? Right? That's that property there. So therefore, that cancels out to be 1. Okay? So when you see e to the ln, that becomes 1, and therefore that's your answer. Make sense? Yes?
Yes.
Okay. So this is a property, you guys. These are properties. Okay? So these are rules I'm telling you exist. Alright, so now we have the ln e to the x minus, I think it's x minus 1, right? Okay? Alright, ln e equals 1. Okay, so this is another property. ln e equals 1. So I have two log properties where they equal 1. I have two ln properties that equal 1. Okay, so therefore the answer on this one is what? It's just, well, this right here evaluates to 1, so what am I left with? X squared minus 1. Right? Because this is 1. So now I just, x squared minus 1. So, yeah, so how does that work? Well, let's look at this. ln can be written as what? Log base e, and then that's to the e, right? So this ln can be written as log base e. It's to the e, x squared minus 1. Therefore, these cancel out as 1, and then this is my answer. So these are just two properties that you want to recognize. Okay, so I've written them up here. Yes? Yeah.
What happens to the e to the ln? Because there's that 1 right there. That doesn't just disappear, does it? I mean, on b, that 1 that...
Well,
e to the e.
Okay, so let's say I had this. I have e to the ln 21, right? Well, what's e to the ln? It's 1 to the 21th power. What's 1 to the 21st power? That's 1. Same thing with here. This is going to be 1 to the x squared minus 1, so therefore that's going to become x squared minus 1 is your answer.
Okay.
Yeah, I mean, that's a good point to make. That's why that works.
I was wondering.
Okay? All right. So now, as with logs, you guys, you have to rewrite e's, right? So they want us to rewrite it with the ln or e. So basically, if it's an e, it wants to go to ln, and if it's an ln, it wants to go to e. Okay? So we have that backwards and forwards, right? So I have an e, and I want to go to ln. Okay? What we do with this one is, if I go log... So e can be rewritten as log base e to the 5 equals x. So if I would take this and have to rewrite it as a log, how would I do that, right? Well, the e becomes our base, that is our exponent, and then the x is what it equals, right? How we rewrite it. So therefore, what's log of base e? How can I rewrite that? ln, right? 5 equals x.
Why is it
What's that? log base e can be ln. Log base e is ln, another way of writing it. Okay, so remember when you rewrite logs into logs, this base is going to be the base of your log, the x is going to be your exponent, and then the 5 is what evaluates to, right? So that's rewriting it as a log. A log of e can be rewritten as ln. Okay? You don't have to go from this log base e to ln. You just can know right away that e can be rewritten as ln. And so this can be just ln 5, because that's going to be what evaluates to, equals your exponent, because your exponent always is on the right-hand side when you rewrite logs. Okay? On this one here, we're going to go ln to e. So again, going ln to e, well, ln can be log a base e of x. Alright, I'm just rewriting that, and that equals 0.6931. So now that I have it there, I rewrite it as e to the 0.6931 is going to equal x. This, I think, is the most confusing part for students, these two. Okay? I like writing log base e and converting it because then I see it as I've always seen it with logs, and then it helps me convert it. Some students can just go straight from here to there without actually having that middle step. Okay? Whenever you see e, you can just rewrite it as ln. And whenever you see ln, you can just write it as e. You don't have to do this log base e thing in between. Some students can just go straight there. Okay? So this is a rewrite. So that's taking, if you see it as e, it wants it in ln form. If you see it as ln, it wants it in e form when it says rewrite. Okay? Alright, so now we're just going to do the same thing we did before with logs, with natural logs, and solving them. So the same concept. When you see an e and it says solve, you're going to use ln. If you see solve and you don't see an e, you're going to use log. So we had two processes. We solved here. Do you see e's anywhere here? No. So I'm going to use log. On here, do I see e's? Yes, I'm going to use ln's. That is going to be your key when you have these problems on a test, which one to use. Does that make sense? And that, I can't distinguish that enough because students will use the wrong ones. When you are solving for the exponent and you do not see an e, as in these situations, you use log as your base. If you see an e in any of the evaluation, then you use ln as your base. Okay? So we have ln here. So we want to start, again, get everything off to the right-hand side, so we're just left with the e on the one side. So that'd be e to the 3x, and that's going to equal 10. Okay, at this point, we want to raise both sides to ln. So our same base is going to be ln. Okay, so I'm going to have ln of e, 3 to the x, equals ln of 10. Okay, what did I tell you ln of e is? 1. So therefore, ln of e, this is actually 1, so this just becomes 3x equals ln of 10. You can bring the 3x down. You have to, both sides have to have the same base. Right, they're both being multiplied by ln. If I take both sides and multiply by 5, I haven't changed my equation, have I? By multiplying both sides by ln, it allows me to use those properties that I can put into my calculator. Okay? So, are you good with how I got ln of e is just going to be 3x? I'm just telling you that this equals 1.
Oh.
Alright, that's a property that just equals 1, right? Okay? So 3x equals ln of 10. So now how do I solve for x? Divide by 3. So I get x equals ln of 10 all over 3. This I can plug into my calculator. Okay, so I do my ln of 10, or ln of 10 divided by 3, and I should get a 0.767, approximately. So that means if I take E and I multiply through and raise it to 3 times this 0.67, add 5, it should equal 15. So my check is going to be E 3 times 0.767 plus 5, and does that equal 15? No. And I got 15 when I did it. Okay? So that's your check. Okay? Alright, so next one. We have raise this one to both sides. Again, all the constants are on the right hand side, so I raise both sides to ln. And that equals ln of 12. Okay? Again, this becomes 1. That equals 1. So therefore I have x minus 2 equals ln of 12. And then I'm going to take x equals ln of 12 and add 2 to solve for x. Okay, so I take 12 ln, add 2, and that equals 4.48, approximately. So I take E and I raise it to the 4.48 minus 2, that should equal 12. And it does. Okay, so this is my check. Okay, so you guys getting comfortable with how you raise it to the same base and then allows you to solve it through your calculator? Okay, alright. So just like we had with logs in regards to the couple of properties, we have these here, and this is our last two examples, and you guys get to do your homework, okay? Notice how I already have things in ln form, okay? Right? So I can use my properties to solve. If I have ln x minus 3 equals 2, and I just showed you how you can convert this into an e, okay? I want to take this and convert it into an e. So this becomes e squared equals x minus 3, right? So you're going to take it from ln and convert to e, right? So this ln is really like log base e, so that it's e squared equals x minus 1. Are you guys good with how I did that? Because ln, okay, so ln of x minus 3 equals 2. I can rewrite this as log base e x minus 3 equals 2. I need to convert this into an exponential function to solve it. So it's really going to be e squared equals x minus 3. That's the conversion from like a log to an exponential function, right? If you just know that ln is e, then it's going to be e to the squared equals that, because that's how you convert it. Okay? So now I have e squared equals x minus 3, so x equals e squared plus 3. Right? I'm just solving for x at that point. So e squared, and then plus 3, and that should equal about 10.39. I showed you how I went from ln to e by showing you that ln is actually log base e, and that's why it becomes e. Yeah, this is just to show you how you can go from ln to e if you don't see it. ln log base e and then e squared. Yes, ln is always log base e. Okay. All right. Questions on that? Alright, so then we have this last example. Notice I have two ln's being added together. What's my property when they're being added together? What can I do? If it was like log of 5x plus log of 3, I'm adding, so there's a property, the product property, right? So I can rewrite this as log of 5x times 3, right? we have two logs being added together, which means I can multiply their value. So I have the same property here, so I would do ln of 2x times 3, and that's going to equal 2. Right, so this is using the product property, right? So now I'm in that same situation I was over here. I can rewrite this then as e squared equals 2x times 3, which is really 6x. So e squared equals 6x. So what does x equal? Yep, x equals e squared divided by 6. Okay, so you use the property to pull them in together as 1, then you can convert it to an exponential function, and then you can solve for x. So you're doing the same thing you did with logs, but they're just ln's. And so when you plug it into your calculator, you're dealing with e's versus log. Okay? Alright, so just to kind of go over, I know this was a lot, you guys. Let's kind of start from the very beginning. Alright, you guys, we learned about the common log, which is base 10, and then the log base e, which is the natural log of ln. Okay? We learned how to put it in a calculator to get values. Yes?
The one that we just did, can you solve it?
Oh, sure. Yeah, so you would have e squared on this one here, and then you divide by 6, and you would get approximately 1.23.
Wait, how did you do squared on this?
I did 2, and then second e, and then divide by 6.
Can we leave it as x equals e to the second root of 6? Or do you want us to solve that?
So again, we talked about the log base 10 and log e, which is the natural log. Hopefully you're comfortable with putting it into your calculator. We learned how to solve for the exponents by raising both sides to log 10. Okay, and that allowed us to work through to get an answer. Okay? Because you can put log 10 in your calculator. So we just worked through a lot of different examples on that. We talked about the change base. Let's say you have a log here that's not a base 10. If you just divide what's evaluated to divided by the base and log, then you should actually get what the answer is. So you can actually take any value and put it in your calculator. We talked about the natural log being a value of e. Okay? And that you can do the same thing with converting it. Okay? You can go from e to ln and ln to e. And that how you can solve for it is by raising it all to ln. And then you use these properties up here where ln equals log base e. You have ln of e equals 1. Oh, the one I didn't put up here was e to the ln equals 1. Okay, so those are all properties you can use throughout this. Okay?